Stop to think about your favorite t-shirt? I mean, really think about what it took to get that color just right. It's not just some simple dye job. There's a ton of hidden science and chemical engineering going on behind the scenes. Today, we're going to pull back that curtain and look at the invisible battles being fought inside dyeing machines to save your clothes from total disaster. So, it really all comes down to this one question. When a company is making thousands of shirts at a time, what's that one little thing that can go wrong and just ruin everything? You'd probably be surprised to hear that the answer is something so small it's practically invisible. You see, on one side, you've got the dream, fabric with that perfect even color, a texture that's soft and smooth, just a flawless finish. But on the other side, oh man, the risks are huge. We're talking splotchy, uneven color, nasty chafe marks and creases that wreck the fabric for good, and even massive machine stoppages that cost a fortune. The line between a perfect batch and a pile of garbage is razor thin. Okay, so let's introduce the villain of our story. And it's not what you think. It's not a clumsy worker or a bad batch of dye. No, it's something way sneakier. These hidden flaws that creep into the process when you're not looking. It all kicks off with this little chain reaction. So, inside a modern dyeing machine, which is just churning away at high speed, air gets whipped into the dye mixture. It's unavoidable. Then, tiny little air bubbles grab on to the fabric fibers. And since a lot of modern fabrics are hydrophobic, they naturally repel water, the bubbles just love latching onto them. And here's the real kicker. Those bubbles act like tiny little shields, physically blocking the dye from ever reaching the fabric. And the result? A ruined product. And this quote, it just nails it. When you get enough of those tiny bubbles together, they create foam. And that foam creates what is basically a massive traffic jam inside the machine. The fabric can't move around smoothly, which causes those ugly creases and chafe marks we talked about. It can even bring the whole multi-million-dollar operation to a screeching halt. But hey, where there's a villain, there's got to be a hero, right? So it's time to meet the specialized solution that's designed to fight this very specific and very expensive problem. Okay, the hero's official name is a penetration accelerant. It sounds super technical, I know, but its job is actually pretty simple. It's a chemical agent with a very particular set of skills, and it's designed to clear the path so the dye can do its job perfectly. For our example, we're going to look at one called ElbaFlow FFC01 just to see exactly how these things work. So how does an agent like this actually take down the foam monster and its bubble army? Well, it doesn't have just one superpower. It's got three. It's a full-on triple-action solution that attacks the problem from every single angle. Its first power is de-aerating. It goes right to the heart of the problem, those microscopic air bubbles clinging to the fibers, and it just kicks them off. It basically tells the air, nope, you don't belong here, and gets all those tiny shields out of the way. Power number 2 is foam destroying. And listen, this is not a temporary fix. This provides permanent foam prevention for the entire dyeing process. Even in the craziest, most high-energy machines, it stops that traffic jam from ever even starting. And its third power is wetting. By getting rid of all that air and foam, it makes sure the fabric surface is perfectly prepped for the dye. It's like rolling out the welcome mat for the color, making sure it gets absorbed evenly everywhere. So you put those three powers together, and what do you get? A perfect process. You get that gorgeous, even color. The fabric just glides through the machine with no snags. You avoid those expensive shutdowns, and you get rid of the risk of damage. It's basically a complete quality control system, all in one little bottle. Now, it's one thing for a chemical to work in a quiet little lab beaker, but it's a whole other ballgame to survive inside a modern dyeing machine. These things are specifically engineered to handle the absolute toughest conditions imaginable. And I'm not exaggerating here. You should really think of these machines as a hurricane in a box. We're talking sky-high temperatures, intense pressure, and a powerful churning vortex of liquids. Any normal chemical would just be shredded in seconds. Now, let's take a quick look at this comparison. You can see right here how a specialized agent like ElbaFlow FFC01 stacks up against your standard, conventional antifoams. Just look at that action row. The regular stuff often needs to be topped up, but this stuff gives you prolonged, consistent action. And that stability? That translates directly to cost effectiveness, as you can see down at the bottom. You just don't have to use as much of it. So you're probably thinking, okay, this powerful, high-tech stuff must be a real pain to use, right? Well, actually, it's the complete opposite. Let's move on to the application and see how it works. It is an incredibly simple four-step process. You measure it out, you dilute it in some warm water, you give it a little gentle stir by hand, and then you add it to the machine before the fabric goes in. That is it. No crazy equipment, no special training needed. And get this, the amount you actually need is unbelievably small. We're talking just zero point 0.1 to 1.0 grams for every liter of liquid. That is a tiny pinch of this chemical hero needed to protect an entire huge batch of fabric. It just shows you how efficient and powerful the science really is here. So let's bring this all back home. We've just peeled back a layer on the science of perfection, and we've revealed the unseen hero that might actually be responsible for the very clothes you're wearing right now. And this right here, this is the main takeaway. Every single time you pull on a perfectly colored shirt or your favorite pair of jeans, just remember that there is a massive amount of invisible science and brilliant chemistry that made it possible. It's a tiny battle, fought on a microscopic level, all to bring you a flawless product. It really makes you wonder, doesn't it? I mean, if this much science and engineering goes into just the color of your t-shirt, what other incredible